Hello, I welcome you all to lesson 2. This is nutrition in living organisms. This is the last part that we did in our lesson 1, classification of carbohydrates. And what we talked about was that we've got 3 classes. The first class, we get to have what we get to call the monosaccharides. I also gave you examples. The second one that you need to know, they are what we get to call disaccharides. So they are what we call disaccharides. So these ones, we looked at them last time when we met for lesson 1. And I told you that this one, when we saw a saccharide, so these classifications, we are basing them on sugar molecules. So this one here, when we say a saccharide, meaning that this is a what? This is a sugar molecule. This is what I told you last time. And the word mono, it is just a number. Mono means what? Mono means 1. And I also told you that di means 2. And saccharide, this is just a sugar molecule. Have you seen? It is a what? It is just a sugar molecule. So when we say disaccharides, we are talking about sugar molecules. We are talking about two sugar molecules. But mono, we are talking about 1 sugar molecule. And the third thing that I want you to understand now in this lesson is what we get to call polysaccharides. So these ones are called what? Polysaccharides. So polysaccharides, poly meaning what? Meaning many. So this is what you need to understand. Poly means what? Means many. So whenever we are talking about a polysaccharide, you need to understand that first, this one, we know that these ones mean what? We are talking about a sugar. So when I say that this is a polysaccharide, what I mean is that these are complex carbohydrates formed by long chains of monosaccharides units linked together by what we get to call glycolytic links or bonds. So what I mean is that these ones are joined together by what we get to call a glycosidic bonds. They are joined together by this bond. This is what you are supposed to know, and these are certain things that I want you to understand. So you need to know that these ones, they just get to have many what? Many sugar molecules. And examples of these polysaccharides, these two I gave you examples, I explained. So examples of these polysaccharides get to contain starch. So they get to contain starch. They get to contain what we call a glycogen. They also get to contain examples: cellulose, chitin, pectin. All those are what? Examples of polysaccharides, because they get to contain many sugar molecules. We are basing these on sugars. So I want you to understand this, and I want you to know. This is where our lessons for today starts from. We are now starting on these things. So we are going to start with starch. So we are now starting starch. So I want you to understand this. The first thing that I want to start with is what? Is starch. So under starch, this one is now testing for what? Testing for starch, or I will just say testing for food substances. So testing for what? Food substances. This is what I want you people to know. So if we are testing, you discover that we are going to have full understanding on these things when we are in the laboratory, where we are able to see the apparatus, we are able to know where these are changing from, where we are testing them from, so that you get to have a full picture, like we know that men think in pictures. So I just want to give you a theory of this thing. So the test for starch is commonly performed using iodine solution. So this is a reagent that is used. The reagent for this one is called what? Iodine solution. We get to use the what? Iodine solution. This is what you need to know. And this iodine solution is in brown. So this is brown in color. So you need to understand that this is what? Brown in what? Brown in color. This is just the theory part, and I want you to understand this theory part so that some questions that you get to encounter or see in an exam, you will be able to understand them clearly. So you discover that whenever we are testing with this, so when we get the iodine solution which reacts with the starch to produce a characteristic blue-black color. So yes, is some simple procedures that you get to conduct for you to test for starch. So you need to understand that this is brown in color, and I've told you this. And for you to know that starch is present, there must be a blue-black. But I'm going to explain even as we get to move on. So this is just a theory part, and I just want you to understand some basics. These are certain basics that you have to know. So we get to look at the materials needed. So the materials needed. The materials needed, you need to have the iodine solution. So we are supposed to have the iodine what? Iodine solution. I just want you to have a picture. This is a theory part, so we won't go that detailed. I just want you to have the foundation of this. So we need to have the iodine solution. Apart from the iodine solution, you also need to have a sample to be tested. So the sample to be what? Sample to be tested. So I'll try by all means to also explain this, how this gets to happen and how you can understand them clearly. Aside that, you need to have a dropper. You need to have a what? We need to have a dropper. A dropper must be there. Aside a dropper, you can also use a pipette. So you can also use a pipette. You need to have a white towel or a plate for better visibility. So these are certain things that these are the materials that you need to have. Even as I'm teaching you, you are also writing down these things. So you also need to have what we get to call a white towel. Have you seen a white what? A white towel. For what? Better visibility. So I'll say for what? I'll say for better visibility, so that you are able to see clearly. So this is what you are supposed to know and understand. Then the procedure that you need to do, the first part is the preparation. So if testing a solid sample, you have to crush that. So the first one, so we are now, so this is the materials needed. Then we move to procedure. So you are writing down these things so that you are able to revise through. So the first part, you get the thing that you are testing first. So the first part is where you get a solid sample. Have you seen solid sample? Then solid sample, what do? You crush it. You need to crush it. So you crush it into a fine powder. Have you seen? Into a fine powder to increase the surface area. After you are done with that, then you put it in the what? In the test tube. You put it in the what? In the test tube. Then you add some water to it. When you add some water to it, that's when now you get the iodine solution. you get the iodine solution. So I'm just summarizing this so that you just have a picture on how to test for starch. These are practical things that you get to do. So I want you to understand this. You get now the what? Iodine solution. You get the iodine what? Iodine solution. So iodine solution using a dropper. So you add a few drops of iodine solution direct into the sample that is in the test tube. So you now discover that under those observations, you are going to observe any color change. So you observe any color change, and you are going to note that the thing that you are going to note is that if it is a positive result, a blue-black color change indicates the presence of starch. So what I mean is that you note, so you need to note that a blue-black, notes this one gets to do what? This one indicates presence of starch. So right, indicates what? It gets to indicate presence of starch. So we get to talk of presence of what? Presence of starch. This is what you need to know. And if there is no color change, the solution remains brown, it indicates that the starch is not present. So I guess we are getting certain things here. So this is what you need to know. This is testing for starch. So what I've told you is that if you are testing, for example, you get a potato, you crush that potato, then you smash it like that, it becomes like a powder, and you add some water so that it forms a solution. Then you put that like 1 cubic centimeters into the test tube. Then you add few drops so that you get to observe a color change. If it doesn't change, it means that starch is not present. But if you note a blue-black color, that means that starch is what? Starch is present. Those are certain things that you have to take note of. So I want you to know that. I want you to understand that. So this is what you need to understand. This test is specific for starch and can be used in various applications in getting food testing and biological studies. So make sure to handle the iodine solution with care, as it can stain skin and clothing. So make sure that you take this seriously, and make sure that you put all your mind to this. So this is all that you need to understand. The next thing that I want us to look at is what we call test for reducing sugars. So test for what? Reducing sugars. This is the next thing that we are going to look at. These are things that come in practical, and I just want us to look at them so that we have a clue of things we get to expect when you are testing food substances. If you are testing for starch, testing for reducing sugars. So the next thing here that I want us to look at is testing for what? Reducing sugars. So we are doing what? Testing for what? Testing for reducing sugars. So I'll say reducing sugars. How can we understand this? So if we are testing for reducing sugars, there are certain things that you have to know. So test for reducing sugars can be performed using a reagent that we get to call a Benedict's. So what we call a Benedict's what? Solution. So this Benedict solution, you need to understand that it is blue in color. It is blue in what? Blue in color. This is what you have to know and understand. It is blue in color. This one is what? This one is blue in color. So when a solution changes its color, so in the presence of reducing sugars like glucose and fructose, you discover that there are certain things we get to observe. So what are certain materials that you need to carry with you? So materials that should be present. So materials needed. These materials needed are I guess you're writing down these things. I'm just summarizing this so that you try to understand. You need to have the Benedict solution itself. So you need to have a Benedict solution. So a Benedict solution must be there. You need to have a sample that you are testing. You need to have a test tube. So a test tube should be there. You also need to have a heat source. So you need to have a heat source that can be a basin burner. You also need to have a dropper. So these are certain materials that should be there. So the first procedure is where you get the sample, dissolve it in small amount of water to create a solution. This is what you are going to do. So you get this one, you put it in the water to create a solution. Then you get to add. So next step, this is a procedure. So this is a procedure. So the first one is where you get the what, if you've got a solid sample, so you dissolve. What you are going to do is you dissolve. So we say dissolve a small amount, dissolve a small amount. So I'll say small amount in water. Small amount in what? Small amount in water to create a solution. To create a what? To create a solution. So we are creating a solution here to create a solution. After that, you add the Benedict solution. So add the what? Add the next procedure is add the Benedict solution. We add the Benedict solution. So add the Benedict solution in the same test tube. So you add the Benedict solution of about, you combine it with about 2 milliliter of the sample with the Benedict solution. Heat the mixer. So next step is where you do what? Is where you heat the solution. Heat the what? Heat the solution. So the next step is where you heat the solution. I just want you to understand this. You heat the what? You heat the solution. After heating the solution, you need to understand that you press the test tube in a boiling water bath for about 2 to 5 minutes. Then after heating, you are going to observe a color change. So this color change that gets to be present, if you want to expect a positive result, so if you are expecting a positive result, if it is a positive result, meaning that a color change from, you are going to have a color change. So for a positive result, meaning they are present, meaning you get to expect a color change. You get to have a what? A color change. Expect a color change from what? So from blue. So a color change from blue, then it is going to change to what? To green. This is what you are going to see even as you are doing all those experiments. From green, you discover that it is going to change to yellow, orange. So yellow, orange, or maybe it can be a brick. I would say it can be a brick red. A brick red. So it can be a brick red. So this brick red gets to indicate the presence. So all these colors indicates, they get to do what? They get to indicate the presence of they get to indicate the presence of reducing sugars with the intensity of color reflecting the solution. So they indicate the presence, I would say presence of reducing sugars. It indicates the presence of what? Presence of reducing sugars. So I just want you to have a picture. These things, you are going to understand them very well when we go for practicals. And if the solution remains blue, no reducing sugars are present. This is what you need to know. So these are certain simple things that you need to take note of. And I just want you to have a picture of these things. So I guess you are getting something. Let us now go to the last one. Then we are done for today. So tonight, I just want you to have a picture on these things. I just want you to have that picture of how these things get to take place. So this testing for food, you are going to have a full understanding as we go for practicals. So even as we go for practicals, we are going to understand these things. So the last thing that I want us to do is what I call test for what? Test for non-reducing sugars. Non-reducing sugars. This is what I want you to know. Test for non-reducing what? Non-reducing sugars. So to test for non-reducing sugars, such as sucrose. So we test for what? We get to have sucrose. You can use a two-step process involving hydrolysis followed by the Benedict test. So non-reducing sugars do not react with Benedict solution directly. So they must first be broken down into their constituent reducing sugars. And the steps that you are supposed to understand are these ones that I'm going to explain. And you need to understand that these sucrose, the sucrose, these are what? Disaccharides. These ones we get to call them what? Disaccharides. So this is what you have to know. They are called disaccharides. And the materials that are needed. So materials needed. Materials needed. So I'll say materials needed. The materials needed. One, we need to, so these ones you are going to help me. You are supposed to be writing them down. So you need to have a sample to be tested. You need to have a Benedict solution. You need to have a dilute hydrochloric acid. You also need to have what we call a test tube, heat source, and a dropper. So these are certain things that you need to have. So let's make sure that we understand these things. Then the procedure that we have to do here, the procedure that we take here, the first step one is what we get to call hydrolysis. This is step one. So testing for non-reducing sugars. So the first step is the hydrolysis. Number one is where if testing a solid sample, dissolve that small amount in water, add the acid in a test tube, add about 2 milliliter of the sample solution and 2 milliliter of dilute acid. So you get to add the acid. Then heat the test tube in boiling water for about 5 minutes. So this will hydrolyze the non-reducing sugars into reducing sugars. So this is what gets to happen. The last step is where now you neutralize. So you get to neutralize. So after heating, you remove the test tube and let it cool. Then carefully add sodium carbonate until the solution is neutralized, where bubbles are stopped or bubbles are not seen. So these are certain things that you get to do. Step number 2. So I'm just giving you these steps so that you get to have some ideas. Even as we go to do practicals, we need to make sure that we understand these things. So once the solution is neutralized, you need to add. So the first step is hydrolysis. Second step is what we call a Benedict. So a Benedict test. So here we ended on the part where the solution is neutralized. So you are right what you are understanding. So what I'm telling you is that once the solution is neutralized, add 2 milliliter of Benedict solution to the test tube. Press the same test tube, you heat again, you press the same test tube in the boiling water for about 2 to 5 minutes. Then after heating, you observe a color change. So you get to observe a color change. You discover that if a color changes, so if color changes from, so if it changes from blue, so if changes from blue to green, changes from blue to green, or yellow, or orange, or brick red, or brick red, or when it changes to brick red, you discover that it indicates the presence of reducing sugars. So these are what you are supposed to know. But originally, from non-reducing sugars, I don't know if you've gotten the point. So when that changes, you discover that there's gonna be some presence of reducing sugars. But originally, from non-reducing sugars, so if the solution remains blue, it means non-reducing sugars are absent. So if these ones changes, if there is a color change, it means that there is a presence of non-reducing what? Non-reducing sugars. So you need to understand that this method effectively detects non-reducing sugars by first breaking down them into reducing sugars, allowing the subsequent analysis using the Benedict solution. This is what you have to understand. So these are certain things that you need to take note of. So tonight, I just want, so if these color changes, it means that there is presence of what? Presence of non-reducing sugars. Non-reducing sugars. Non-reducing sugars. And if no color change, so no color change, let me do this. No color change. No color change. No color change. This one indicates the absence. So it indicates the what? It indicates the absence of what? Absence of non-reducing sugars. Absence of non-reducing sugars. This is what you are supposed to know. So this is where we end from. I guess you've gotten one or two things from the beginning of this lesson. You are going to understand more when you go for your practicals. This was just a theory part to make you understand this. We are yet to do more when we start the practicals. So this is just a simple part on these things. I guess you've gotten one or two things. Thank you so much. So write down these things. It's a continuation from where we ended. Thank you.